So we've got this Cyrus1 amplifier here, one of the earlier models, and one of the channels are apparently not working or intermittent. So let's get the covers off and have a look inside. Okay, so we've got the covers off, and there's nothing actually blown up in this amplifier. It's just age that's really the problem, and some intermittent connections and the like. So the main thing that we see in the Cyrus is they use these ALP switches, and basically the contacts of these over time, they just get tarnished and then don't make contact. And every amplifier this age is going to have that problem. It's got nothing to do with how well it's been taken care of or how it's been used or anything like that. Every single amplifier will have a problem with these switches at some point in time. The other one is the switch here for the moving magnet and moving coil phono inputs. Same problem, just over time that gets tarnished and needs to be dealt with. The other thing with amplifiers this age, we've obviously got all these electrolytic capacitors, and they are basically going to go dry. And if we quickly bring in the ESR meter, now electrolytic capacitor I'm expecting to be sub 1 ohm, and if we look at one of these orange guys here, just pick one at random, I'm way over 20 ohms, so that capacitor's basically dry. Compare it with this one next to it, and it's fairly okay. So we kind of know that all of these are going to need replaced, and these are in the phono preamplifier section, so who knows what the frequency response to that is going to be like in the current state, and we'll maybe have a look at the graphs of that later. But we're going to replace all of them. We're going to take these switches off, take them apart, clean them up, and see where we end up then. So let's go ahead and take these apart. Okay, so I've removed these switches from the amplifier and taken them apart, and this is the set of contacts for one of them, and you can clearly see the tarnishing over all the contacts there, but particularly this end. And this end is the exposed end of the carrier there, and so that's maybe why it's much worse than anything else. And these end contacts, they're used for the phono section switching, and so you find with these amplifiers that it's always the phono section that goes first, that starts to go a bit wrong before the rest. And this is the reason. It's just basically because these contacts they're just not reliable. You're not getting a good connection made there. So obviously we need to clean this up, and that should help us out. So I've already done one, and you can see the sort of before and after there. Very, very clean, and these should give us a much more reliable contact for a good long time to come. So we'll put these switches back together now. I'll clean the other one first, and we'll put them back together and get them back in the amplifier. Okay, so we've put the amplifier back together, and we need to think about making some measurements to make sure everything's as it should be. And I spoke about the electrolytic capacitors being dry and how that would affect the phono preamp and the response of that phono preamp. So those capacitors are being replaced, and so if we look at the standard, this is the phono equalizer standard that you'll see anywhere on the web, so we're looking for something that represents that, and this is a measurement on the Cyrus, and it matches very closely. The only difference is down at near the low frequencies here, near DC, where it kind of tails off a bit, and that's just because it's not a DC amplifier. It's got some AC coupling in there, so you see that corner there, then it tracks very, very well, so quite happy with that. I'm only showing one channel here, the other channel was identical really, so okay. So the next thing then, we want to look at the line channels and see how their bandwidth looks. The spec, Cyrus spec, says 3 dBs at 50k.
and what I measure is it's up to about 80k by the time it's 3 dB down. So that's got a good bit of margin on target spec, and quite happy with that again. So this last result here is the most interesting one, where we start talking about power and distortion. And when I was working on the inside of the amplifier, I had to reset the bias. That's something you would do anyway. And normally you've just got this variable resistor somewhere, and you adjust that, and you know adjust that to get the right bias level. In this case, I couldn't do that. The resistor was at its end stop, and I couldn't get any bias on the thing at all. And what's happened here is, just because of the age of the devices, the characteristics have changed over time, and this is quite a simple bias circuit. It's no longer got the range to be able to give you the settings you need. So in actual fact, I had to reduce the value of this resistor, and then I could adjust to where I want it to be. So once all that was sorted, we started to look at making distortion measurements. And what I'm showing here is, I think this is full scale, running at full power, and so we've got 23 dBV on the fundamental, which is equal to 25 watts into 8 ohms. And we can see that it's the third harmonic that's dominant here, and it's about minus 70. So that's a 93 dB difference, which is very good. And when we look at the target spec, they're talking about 86 for THD plus N, so that's all of the harmonics and all of the noise. They're looking for 86 or 0.005%. What we measure is 89 and 0.0037%. So quite happy with that result also.
So before we pack the amplifier up, we want to test all the inputs and make sure they're all working fine. And so I've got the amplifier connected up to some speakers, and we'll just work through each of the inputs and switch through them. And what I'll do is I'll disconnect one channel of input at a time, and we'll still hear the sound. Obviously I can't do stereo on this camera. So what I've got here is just a little adapter thing here that takes a line level input and changes it to phono level, so that I can do my phono input here. So let's have a listen.
What I so clearly could see.
And we'll switch to that's moving magnet, we'll switch to the moving coil. So that's all good. Let's now look at some of the line inputs. So we take our source and we'll go in, just go front to back here. So this is our CD, and if we change our input switch, to the tuner. We'll just put the one in at a time.
He cares. I will always remember.
And then the last one's the tape.
That we share.